gonna be here. How big is it?
That one was W over 2.
This one?
5 over 2W.
And the length, each one of them is A, yeah?
Yeah. Christmas music's going on, isn't it?
Hmm?
Christmas music's on again.
Not Mariah Carey.
Yeah. Right. Now, the second step which you have to do, now consider the shear force S and bending moment M at the point P on the beam, where AP is equal by X. Do you remember? What have I done? It means you have to start cutting the beam across. Okay? And when you do the cutting, before each concentrated level. Before and after each concentrated level. Does it make sense?
Yes.
How many cuts would it be in general?
Oh, this one.
3.
Did you hear that?
3.
When we do the cutting, in order to draw the bending moment shear force, before and after each concentrated level. Can I do before here? There's no big. Before, after, and before this one. And in here, after and before this one. And in here, after and before this one. And here we cannot cut. Okay, so strictly speaking, the best way to do that, before and after each concentrated level. So I'm gonna go pretty quick on that and solve it. I would say, I would take X bigger than 0, less than A. First cut, watch me. It means this cut, it would be X, ladies and gentlemen. And this is going to be a 1 over W, yes, W over 2. And you cut it at the point P. When you cut, is a point P, and it would be creating the moment. And this is creating the shear force as well. Are you with me? Yes? It's not considered P. Can you see that shear force goes up? In some places, my old lecturer used to put it downward. It's not a big deal. Same things. Because he took this one downward, the other end the cut, take it upward. Okay, so, and then you need to create a bending moment and the shear force diagram. Note, there are a concentrated force, and hence, this continues at the B and C. So it is necessary to consider separately the section for each section. The first section, X bigger than 0, less than A. The other one would be, how many cuts I'm going to do that, as you said? Can you put the cuts here? X bigger than 0, less than A. Next one, X
Bigger than A.
less than A.
2A.
Next one,
Less. Bigger than 2A, less than 3A.
well done. That's the way it goes. Before and after each concentrated level. And let's do here. This is the point A. At the point P, I cut it. And at the point P, can you see that? What did I create at the point P? I will create a force. I would create a moment at the point P, which is the moment A. And this is the point A. At the point A is R as well. Okay, use the shear force and diagram. Let's start with the shear force. Shear force, it means force upward, yes? I put it arrows, I put it in shear force. So start from this point. S goes up, plus W2 goes up. Anything else? Equal by 0. So therefore, my S is equal by minus W over 2. Happy?
Yeah.
And the moment about P. So you said moment about P. Or P, you put a rotation, is a moment. Let's take a moment about P. Put my finger there. At the point P, is there any moment?
Yes.
Yes.
When I cut it, I rotate. So there is a moment at the point P. So M is there. I put my finger here. This W2W, S, would it create any moment about the P?
Yeah. W.
No.
Say that again.
If I put my finger at the P,
Alright.
the force S, shear force, would it create any moment
No.
as
Oh,
well?
no.
Yes or no?
No.
Why?
'Cause,
S times 0.
yeah.
Force goes through point P. No zero, no distance. When I cut it, I rotate, I just collapse, I went down.
Mm.
But that S doesn't create another moment for the rotation. So, but this one does, yeah?
Yeah.
W2 times X, am I right? And therefore M is equal by WX over 2. How beautiful? Another equations. Yes? Next cut. X bigger, 2A, no, bigger than A, less than 2A. Let's draw the pictures. How many forces would I have? Where did I cut? At point P. When I cut at point P, it was shear stress, yeah? Goes up. And it was a moment as well, yes? What's the distance of the cut?
Between A and 2. Between A and 2A.
A and P. And this is a B. What's the distance of the cut?
2A.
Always X.
X.
Always X. Always X. Okay. This distance, how big is it this distance, Hamza? From here to there.
That distance would be
Let's use
Half.
Greek.
half of x.
Would be half of the X,
Half
this
of the
distance, you reckon? Hamza, what's the distance
Yeah.
from here to there?
That's x.
What's the distance this bit?
That would be
What's that?
one of half of x.
Delta.
Delta. I'm not.
Well, right, because you are not following, sir. Watch. Hamza, from here to here is A.
Hmm.
From here to here to A.
Two,
yeah.
yeah. Two, yeah.
The first cut, I made it from here to there, somewhere here. I don't know where is it. That's why I call it X. Can be here, can be there, can be there, can be there, like that. But I know bigger than 0 and less than an A. I cannot cut here. I have to before. Does it make sense? So I put a range. This speed, it can be X. Can you see that? Bigger than 0, less than an A. Next cut going to be after this one, before that. Can be cut here, can be here, can be anywhere.
Ah,
So from here to there, cut, I call it X. Point of the cut, I call it a P. At the point of the cut, it's a shear force.
Shear force.
It is a bending moment we created. That is X. I don't know how big is it X. But
so
I know from here to here, how big is it?
it's a bit, it's more than,
Now,
so it's
So that is A.
Yeah.
I already cut it. This is X,
Hmm.
which is bigger than A, less than 2A. From A to point P is X. From A to B, how big is it? How did I know that? How big is it from here to there?
that's A.
A.
Yeah.
So from here to there
It
is
would be
A.
X. Would
It's
be-
not X. I know.
A.
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 From here to here is X. The X means I don't know. If 1 meter, 2 meters, I cut it before 2 meters, can be 1.98, can be 1.18, or it can be 1.38, 1.8, but it's bigger than 1 meter. So this is A.
It's A.
What would be this bit?